Hi, this is Sonia Doucette. In this video, I'm going to show you how to prepare solutions using volumetric flasks. So the first problem says you have a 500 milliliter volumetric flask that you can use to prepare a 0.15 molar solution of NaCl. How many grams of NaCl should you add to the flask to prepare this solution? So you can start with what you know. You know that you want a 1.5 molar NaCl solution. So what does that tell you about the solute and the solution? Well, if you have 1.50 molar solution, you know that you have 1.50 moles of sodium chloride per liter. So that's a start, because what you want to know is the number of grams of sodium chloride that you should weigh out on a balance to then add to the volumetric flask to make your solution of desired molarity, which is 1.50 molarity. So you want to get to grams of sodium chloride. So in order to do that, you can use the molar mass of sodium chloride, so it's 58.44 grams of sodium chloride in 1 mole of sodium chloride. So that is going to give you 87.66 grams of sodium chloride per liter of solution. So we still have that liter in the denominator, because if you look back at what cancels, you cancel moles of sodium chloride, but you're still left with the units of liters, and you're left with the units of grams of sodium chloride. So that's why your answer is in grams of sodium chloride per liter. You're not quite there yet, because you know the grams of sodium chloride you want per liter, but you don't know how many grams yet to weigh out on the balance. So you have to relate that to the volumetric flask that you're going to use. So you're going to use a 500 milliliter volumetric flask. So now you know a volume. Your desired volume is 500 milliliters. So you want to relate that 500 milliliters to the liters. So you're going to have to convert it to liters. So you have 1,000 milliliters in 1 liter. And now you can just multiply by the 87.66 grams of sodium chloride per liter to get to grams of sodium chloride per liter. Because when you do that, liters will cancel out, milliliters will cancel out, and you'll be left with grams of sodium chloride, which is what you want to solve for in this problem. So when you do that, you'll get 43.8 grams of sodium chloride. So this type of problem might occur in a situation where you have an unlimited amount of sodium chloride solid back in your stock room, and you can go grab that bottle of sodium chloride and weigh out as much as you want and just pick a type of volumetric flask. In this case, you picked a 500 milliliter volumetric flask, and you know the molarity of the solution that you want. So you're figuring out how many grams of that NaCl to weigh out. So let's say there's a scenario where you're limited in the amount of solid salt that you have back in your stock room. So here's another problem that illustrates that. So let's say that you have exactly 42.0 grams of potassium fluoride salt. You don't have any more than that available. And with what you have, you want to prepare a 3 molar solution of potassium fluoride. And then you only have 3 volumetric flasks that you can use. You have a 150 milliliter volumetric flask, a 250 milliliter, and a 500 milliliter. Which of those flasks should you use to prepare the 3 molar solution? So the first thing you want to do, because we're thinking about molarity again, you know that molarity is moles per liter. So what you're desiring here is 3 moles of potassium fluoride per liter of solution. So that's what you want to find. So let's convert, to start, the 42.0 grams of potassium fluoride salt to moles. So the molar mass is 48.1 grams of potassium fluoride per 1 mole of potassium fluoride. So you'll get something like 0.7228916. So I'm just leaving that number expanded and not rounding it to sig figs yet, because we're going to want to use that in some more calculations here. So that's the number of moles of potassium fluoride that you have to work with. So now you want to find out, well, which of those 3 volumetric flasks would be the best one to use. So you want to figure out basically the volume that would get you to that 3 molar solution of sodium fluoride potassium fluoride, given that you have this many moles of potassium fluoride to work with. So what you can do there is just do some tests. So what molarity would you get if you put that 42 grams of potassium fluoride into the 150 milliliter volumetric flask? Well, let's just determine the molarity there, like we did in the previous problem. So you have 0.722896 moles of potassium fluoride, and you're using the 150 milliliter volumetric flask. Because you want molarity, which is in moles per liter, you have to convert milliliters to liters. So you can do that right in the denominator. And what you would get is something like 4.819, which you can round to 5 molar. So if you put that 42.0 grams of potassium fluoride into that 150 milliliter volumetric flask and then filled it up with water, you'd end up with a solution that was 5 molar, and that's not what you want. You want a solution that is 3 molar. So let's try the next possible volumetric flask. Doing the same exact thing. You have 0.722896 moles of potassium fluoride, and your next volumetric flask, your next size, is 250 milliliters. Converting that to liters, because we're dealing with molarity. And when you do the math there, you'll get 2.892. So is that good enough? Well, yes, because the limiting digit here for significant figures is the 3 for molarity. So we only have 1 sig fig here. So you can round this number, the 2.892, to 1 sig fig, which is going to give you a molarity of 3. So the answer is you'd want to use the 250 milliliter volumetric flask to prepare this solution.